All right, so today we're in our last lesson for chapter 15, operations and scientific notation. All right, so operations mean the addition, subtraction, multiplication, and division. So you cannot add or subtract in scientific notation unless the exponents are the same. So that's what we were just talking about, the common power. When I'm adding and subtracting, I must have a common power. So we're also going to sometimes need to manipulate the powers. What do I mean by that? Maybe if I'm adding and I don't have a common power, I need to somehow create that. So here's my rule. To increase the exponent value, let's say I need to take 10 to the third power up by 1 and make it 10 to the fourth power. Here's what I'm going to do. I'm going to move the decimal to the left and the number being multiplied. So I want you to think of it like a pulley system. All right? If I need to increase my exponent, I will shift my decimal to the left, and those actions offset each other. Okay? So that's what I see here. I had 2.3. Well, if I need to increase my power, I just simply shift my decimal to the left that many places. And then it's the same thing. You guys with me so far? Okay, so let's do our operations. Okay, so in example 1, I'm going to add and subtract with the same power. So we think of that like common denominators. We have a common power, so we don't have to mess with that. All right, I'm just going to bring down my common power. Just like when I add fractions, I bring over my common denominator. So you're going to bring down 10 to the third power. That's going to be in your answer. You have a common power. Now you're going to take your decimal values and you will add them together. How did you know to add? Because there's addition in between the expressions. So you have 4.6. You are going to have to do this by hand. Remember, on this test, we have no calculator. 4.6 plus 8.72. Now, what do we want to have above the 2 just for safety, just to kind of be sure? We want to have a 0 placeholder. So now I'm going to add them. 0 plus 2 is 2. 6 plus 7, 13. And then 5 plus 8, 13. So 13.32 times 10 to the third power. This is not my final answer. This number is not written in scientific notation. Why? Is 13 in the range of 1 to 10? It's too big. 13 is too big. So I need to make an adjustment here. All right, so this is that rule that we were just talking about. Which way do I need to shift my decimal so that I then have a decimal value greater than 1 but less than 10? Which way do I need to shift it? To the left. I must shift it how many places? 1 place to the left, which we know is 1 power of 10. So if I shift it 1 place to the left, that means I need to increase my exponent value by 1. And those actions offset each other. So my actual answer is 1.332 times 10 to the fourth power. This number is in scientific notation. Okay, how are we doing so far? Did okay? Now, on the next expression, am I adding? Look at the sign in between the expressions. Am I adding? I'm subtracting now. So my rules for subtraction are still the same in that I bring down my common power. So I have 10 to the negative fifth power. I'm just going to bring down my common exponent, my common power of 10. Now I must subtract, and be careful on this because you have to put the larger absolute value on top. In this case, it is the first number. But what if these numbers were switched? What if 4.5 came first? Well, that number can't go on top. You can't have a negative decimal value, okay? So just make sure you put the larger absolute value on top, and you're now going to subtract the decimal values. What is 7.8 minus 4.5? 3.3. Is this number within the acceptable range for decimal values? Is it greater than 1 and less than 10? Is it? Yes, it is. I only need common exponents, and I bring down my common exponent when I'm adding and subtracting. So now let's look at multiplying in scientific notation. So now I'm multiplying powers of 10. I'm going to show you commutative property. You're not going to need to do this on all of them, but I do think it helps make sense. It helps you kind of make sense of what we're doing. Commutative property says I can rearrange these, okay? I have to do these operations, so don't you think it would be easier if I group my whole numbers together? 3 times 5? And don't you think it would be easier if I group my powers of 10 together? 10 to the negative second power. To me, visually, this really helps. Okay? What's 3 times 5? 15. Now, if I'm multiplying powers of 10, but look here, guys. Do I have the same base? Do I have the same base? Yes, I do. So what can I do with my exponents? That's one of my exponent properties. I can add my exponents. I have the same base. Both of them have a base of 10. So because I'm multiplying, that means I can add my exponents together. 10 to the negative 7th power. Now, I don't want you to worry about having a negative exponent, because that just means that this number is really, really tiny. All right, you don't have to worry about making the exponent positive. But this number is not in scientific notation. Why? Tell me.
15 is higher than 10.
15's too big, right, Nate? 15's too big. So which way do I need to move my decimal? Wait, where is the decimal in 15? It's after the 5. It's at the end. So where do I need to move it?
After the 1.
After the 1. 1 place to the left. What was my rule? If I shift my decimal left, what happens to my exponent? I add it by 1. That offsets what I'm doing. So if I make it 1.5, I must add 1 to my power. Be careful on your signs. What's negative 7 plus 1? Negative 6. This is what gets kids on the quiz and test. Kids, not you though. You guys are going to get it. This is what gets them though. They don't catch that 15's too big, and it messes them up. All right, I want you to do the next one on your own. See if you can get to the answer before I tell you guys what the answer is. All right, Reese, what numbers did you group together?
12 times 6.
Uh-huh.
And the 10 to the 4th power minus 10 to the 8th power.
All right, very good. 10 to the 8th power. Now, this is something that eventually you'll probably do mental math. So it's not required to show this step, but I do think it helps. Okay? What's 12 times 6? 72. Now, what can I do with my powers of 10? Add them together. Is this my final answer, Lucas? No, why not? So how did you write it in scientific notation? Times. Very good. So he increased the power by 1 and shifted his decimal left. How'd you guys do with that? Did okay? All right, very good. Now, let's divide. Okay, now we're going to divide in scientific notation. You could see this stacked as a fraction, or you could see it horizontally. We're going to look at both ways. Now, you will have to do a little bit of long division for your decimals. You must remember that the number on top, or the first number in the division, goes on the inside of the division in long division. Okay? Now, these decimals will not be anything crazy, but you are going to have to divide by hand. All right? Does 6 go into 1? Are you guys writing this down? Does 6 go into 1? Nope. So I need a 0 placeholder over the 1, and I need to bring up my decimal into my quotient. Does 6 go into 18? Yes. 3 times. So that's it, right? Because 3 times 6 is 18, and that zeroes out. Okay, so I'm good. I did the decimal part. Now, what do you guys see here? Could I use an exponent property?
Yes.
Would I add my exponents together? No. What do I need to do? Subtract my exponents. So I'm going to subtract my powers of 10 up into the numerator. So negative 8 minus 7. What's negative 8 minus 7?
Negative 15.
10 to the negative 15. So let's bring our answer together. 0.3 times 10 to the negative 15th power. But this number is not in scientific notation. Why not?
Oh, because it's less than 1.
It's not greater than 1, right? 0.3 is less than 1. So now we have the opposite problem. Now our number is too small. So which way do I need to move my decimal to get me a number within the correct range? To the right. So I'll let you guys take a wild guess at this. If I need to move my decimal to the right now, what would I do to my power? I would subtract by 1. So if I move it to the left and I have to add the exponent, it only makes sense that if I move it to the right, I must subtract my exponent by that many place values. So now I have 3.0, or you could just say 3, times 10 to the negative 16th power. I want you guys to do this one. You guys go ahead and do the next one. 1.5 times 10 to the negative 3rd divided by 7.5 times 10 to the 2nd.
Can we change it into a fraction?
So you can, and I was just about to say, you probably should either stack it as a fraction, like put it like this, over 7.5 times 10 to the 2nd. To me, it makes quotient of powers easier, okay? Or you should do the commutative property where you group them together with a division symbol. But I would tend to agree with Julia. If you're dividing, I would instead stack it as a fraction so I can see the quotient of powers a little bit better. And you can very easily do that. Which number goes on the inside of the division? Which number? No, which number goes on the inside? The top number, the first number. 1.5 goes on the inside. 7.5 goes on the outside. All right? So is 7, hold on, we got to bump out our decimal, right? We can't have a decimal in the divisor. So bump out the decimal. 75 goes into 15. Does 75 go into 15? Nope. So this is going to be a 0. I add a 0 and a decimal after the 15. Now I add another 0. Does 75 go into 150? You might need to mess with that a little bit. Obviously, it's not going to be once, so if you're unsure, why don't you try 2? What's 2 times 5? 10. Carry your 1. What's 2 times 7 plus 1? 2 times 7. 14. 14 plus 1 is 15. All right, so I bring everything down, so I have 0.2. Okay, I see a couple people still writing, so I want you guys to finish this problem. Try to get to the final answer of this problem before I give it to you. Okay, so now I do my quotient of powers. -3 minus 2. What's 10 to the negative third power minus 2? 10 to the negative fifth power. So, oh wait. Did I have my, yeah, I have my 0.2. Okay, so 0.2 times 10 to the negative fifth power. But is this my final answer? Is it, guys? No? What do I need to do?
Move the decimal to the right.
Move it to the right, and if I move it right,
Subtract 1 from
I subtract that many place values from my power. 2 times 10 to the negative 6. All right, so how are you guys catching on to this? Are you catching on okay? All right, so might have been a difficult lesson to teach yourself, right? But when you hear it explained, maybe not so bad. So this might be a homework assignment where it would be helpful for you guys just to turn on the video, right? Even though it seems simple on the step-by-step, it's still a lot to remember, okay? All right, so let's see what it looks like with different exponents. Now, what operation do I have in between my expressions? What operation do I have, guys? Addition. So if I'm adding, I have to make sure I have a common power. Do I have a common power? I do not. All right, so I'm just going to tell you to start with, I'm going to tell you which one I want you to change. I want you to increase the lesser value up to the greater value exponent. So what do I mean by that? I want you to look at the powers. Which one is the lesser value? -3. Would you agree that -3 is less than -2? So I want you to increase the lesser one so it matches the greater exponent. My rule says if I increase my power, I must shift my decimal to the left. So you do need to change this and rewrite it. 0.82 times 10 to the negative second power. So you did that to have common exponents. Times 10 to the negative second power. Now that you have a common exponent, you can bring that down in your answer. Now you can add your decimal values together. 0.82 plus 3.41. What's 2 plus 1? What's 8 plus 4? 4.23 times 10 to the negative second. Is this number in the correct range? Yes, it is. Okay, deep breaths. Look at the next one. Am I ready to add these numbers together? Am I ready? I see some heads shaking no. Lily, what do you think? Am I ready to add those exponents together? Why not? I don't have the same power. So which expression needs to change? The first one or the second one? The second one, right? Because the second one has the lesser value exponent. How many do I need to add to 3 to make it equal to 5? 2. So 3 plus 2 is 5. I haven't seen a 2 yet. If I add 2, how many decimal places do I have to bump my decimal? 2. So bring down your first expression. I'm not changing the first one. 4.7 times 10 to the 5th. Plus, now I have to bump my decimal 2 places, which means I need a 0 in front of the 7. 0.072 times 10 to the 5th. Now that I have my common power, I can bring it down and I can add my numbers together. 4.7 plus 0.072. Make sure you line up your decimals. 4.772. Is this number in the correct range? Okay. Guys, you do the same thing with subtraction. All right, but we've done a lot of problems, so I am going to stop here. I'm going to use the subtraction tomorrow as like a review tool as we start to review product of powers, quotient of powers, negative exponents, and scientific notation. All right, for your quiz on Monday. So we're going to end here for today.